Hi, everyone. First of all, I want to thank everyone organizing this event. It's a great honor to present my work at this 24 hours conference. I'm Makoto Fukushima. I'm a manager at the R&D division at the Deloitte Analytics in Japan. I have a PhD in neuroscience and systems neuroscience, and I'm engaged in all kinds of activity related to neuroscience and neurotechnology. Today, I'm going to talk about evaluating improving the films or movie with neuroscience or neurotechnology tools. So as you may know, that the most of the information processing in the brain is not consciously accessible in our mind. So only a fraction of the information is visible, just like this tip of iceberg in this picture. Neurotechnology is a type of technology developed within the field of neuroscience, which allows us to record the brain activity in order to reveal the unconscious process underlying human behavior and cognition. As neurotechnology can make unconscious process visible, it could provide a new form of communication, enhancing the exchange of information among the people, between the humans and the AI systems in the society. The application of neurotechnology has a potential to transform various domains of involving human communication, such as healthcare, marketing, design, and human-machine interface, among others. As a case study, I will present a study we did last year to evaluate a short film with neurotechnology. As a part of the International Short Film Festivals, we evaluated the short film using neuroscience tools. We have presented the analysis and the results at the Creative Seminars of Short Film Festival in Asia 2022. So you might wonder why we need neuroscience or neurotechnology to evaluate the film. To give you an idea about how it comes about, first let me talk about the limited resources available in our brain. So filmmakers commonly rely on the post-viewing surveys from audience at the previous screening to rate their films. This would require that you participate you articulate what you feel about the film, but sometimes it could be difficult to articulate your impression consciously. Besides, the post-viewing survey would evaluate the memory of experience, not experience itself. So you might have a hard time to remember everything happening in the film. Film presents their stories in a chronological order in this way, and thus audience's brain processing sequentially. For such a sequence of events, the Fry-Machi recency effect in memory suggests that people tend to remember events that occur at the beginning and end more than events that occur in the middle. This is just one example of bias in our memory, and overall, post-viewing questionnaires may result in a fragmentary evaluation based on the memory because of the various types of bias we have. On the other hand, if we record the brain responses to the film while people are watching it, the evaluation doesn't need to rely on the memory or other bias in the self-reporting. Therefore, this could evaluate the entire movie objectively and evenly. This could potentially provide us more useful insights regarding the film. I am not the first to study the film with neuroscience tools. This field of neuroscience is sometimes called as the neurocinematics. There has been neuroscience studies for evaluating a field since 10 or 15 years ago. In the current study, we recorded EEG or brainwave and eye movements from the people watching a short comedy film titled Shav Shav Spirit. The duration of this movie is about 10 minutes, and the data was collected from the 20 participants. First, let me present the results from the eye tracking. So this video shows the results from the eye tracking data. Each point indicates each fixation point from each of the 20 participants. As you can see, those points are attracted to and follows the prominent or salient visual features such as human face. To investigate what feature in the film attract eye gaze, we use an AI model which has been developed to predict eye movements. Here, prediction of the AI model on the right is compared with the actual eye tracking data on the left. As you can see, model predicts pretty well overall for salient features such as human face, objects with quick motion, and so on. On the other hand, we also found that the AI model failed to predict the actual data in certain cases. Here above, this person is looking at the beer bottle held by his hand. In eye tracking data, people tend to look at the beer bottle because we have a tendency to look at the location people are looking. However, the AI model prediction is mostly focused on the human face here because that is a visually salient feature. In the next case in the bottom, there are two faces in the images. AI model predicts the two locations equally salient, but actual eye tracking data is focusing on the person on the left because he is the one speaking in this scene. These results show that the people's attention could be attracted to not only salient visual features, but also some other features such as context or auditory information. So next, I'm going to present the results from the brainwave. Electroencephalography, EEG, records electrical activity in the brain from the electrode placed on the surface of the skin. In 1924, about 100 years ago, EEG was recorded from human for the first time. At that point, nobody actually believes that the EEG actually records electrical activity in the brain. But in 1934, independent confirmation was done at the University of Cambridge, and people begin to realize that this method actually allows for measuring the brain activities. By 1935, first clinical application of EEG for localizing diagnosis of the epilepsy and the brain tumors established. Now, EEG is widely used in clinical commercial application in various situations. Fast forward to the present, this is the EEG headset we used for the current study. We used the EEG feature called frontal alpha symmetry, or FAA, for evaluating the film. I don't go into the detail of how feature is calculated from EEG, but previous studies have shown that the FAA is correlated with the people's motivation to approach to or withdrawal from presented object. For example, if you're looking at something you like, say small cat or tasty food, your approach motivation gets high. On the other hand, if you're looking at something you don't like, say snake, you want to avoid or withdraw from it. This can be quantified, this EEG feature, FAA. Interestingly, FAA is used for evaluating consumer behavior in multiple studies. Here, this graph shows that the results from a study done in a Deloitte Neuroscience Institute at Germany, suggesting that the UX design with high approach motivation leads to better sales. This graph shows the time course of FAA during the watching the movies. As you can see, the approach motivation gets higher in the later part of this movie. So what happened in the first 4 minutes with low approach motivation? This movie is starting from Shuzo. This guy was staring at you like this. Shuzo is the father of a daughter who brings her fiance to their home for the first time. Shuzo has a secret mission to see whether the fiance is worthy or not of marrying his daughter. In the first part of this movie, Shuzo was watching every single move made by his fiance for his table manner. So it gives you the very strong sense of tension for the first 4 minutes. This corresponds to the low FAA value from this EEG. Also, this part is characterized by the low visibility in the image, as you will see an example in the next slide. So this is an example of the low visibility seen in the first part, because the Shuzo is watching the carefully and from the dark place, and this high contrast, low contrast scene is quickly switching. So this may be actually contributing that the low FAA value we observed in the first 4 minutes. Next example shows that FAA is actually helpful in finding hard to hear line and moving moments in the film. Let me play this video. So I don't provide the audio here, and then it doesn't really matter at this point. You don't understand what he said here. But at the beginning, he said something like, "Greetings from the lower seat and the cushion side above me. He was a wonderful man," okay, in Japanese. This line is actually very hard to understand even in Japanese. And this clearly correlated with this low FAA value in this graph in here. So actually, interestingly, when we talked to the director of this film, telling this result, and he actually told us that this is a point where he was also concerned about after he making this movie. So it's very hard to hear lines shown up in this corresponding to this low FAA value here. But after this scene, this graph showing that the FAA gradually gets higher, while Shozo keep telling the positive and nice comments about the fiance. Thus, this part of the movie is nicely characterized by the FAA values, demonstrating that the EEG allow us to detect positive and negative moments of the movie precisely. Also, a high FAA appeared for the funny and the commercial comical scenes. Here is just show some of the example. So it's actually in Japanese pretty hard to understand, but so this part is basically the Shozo was told by his daughter that he is actually she is actually already pregnant. So there are some other things as well, but for example, so this might be quite obvious and maybe universally funny scenes. so this is actually detected by EEG index of features and called FAA. Okay. So just to summarize, emotional and this comical scenes tend to evoke the higher approach motivation found in EEG. Scenes with tense and quiet development, rapid fluctuation of the contrast is very or difficult to hear line is actually appeared in low FAA values. So just to conclude that this case study on evaluating short film showcases a practical application of the neurotechnology. This approach provides a valuable insights into the unconscious process underlying human cognition. Therefore, neurotechnology has a potential to unlock the new opportunities to better understand and enhance the communication among the people and AI. And last, I want to acknowledge our team, the Data Analytics, Tomotake Kozu and Yasutaka Honda, and also from Digital, the Gomi Yoshida and Masaya Mori, and also Keiko Kameda. Thank you so much.